Every time you tap your phone screen, billions of transistors are making a simple choice, on or off, 1 or 0, yes or no. And right now, at this very moment, you're benefiting from a philosophical insight that's older than the Roman Empire, older than the pyramids, older than pretty much any civilization you learned about in high school history. Before we go any further, smash that like button if you've ever wondered where technology really comes from, and drop a comment telling me if you've ever heard of the I Ching. Seriously, I want to know. Now, get comfortable, maybe brew some tea, dim those lights, and prepare to have your mind gently blown by a 3,000-year-old book of wisdom that accidentally invented the future. You're standing in the Yellow River Valley in ancient China, somewhere around 1000 BCE. The air is heavy with moisture and the smell of earth after rain. You're watching an elderly scholar, his hair tied in a traditional topknot, his robes simple but immaculate, carefully arranging a pile of dried yarrow stalks on a woven mat. His movements are deliberate, almost meditative. This isn't some random fortune teller at a carnival. This is serious business. He's consulting the I Ching, the Book of Changes, and what he's doing right now, whether he knows it or not, is performing a binary calculation. Yeah, you heard that right. Binary, the same system your laptop uses, the same code running the video you're watching, the same fundamental logic powering everything from your smart fridge to the Mars rover. And it all starts with some sticks and a really deep question about the nature of reality. The scholar divides the stalks, counts them in groups, sets some aside. The process is complex, almost ritualistic. After several rounds of division and counting, he arrives at a result. He draws a line, either solid or broken, unbroken or divided, whole or split, 1 or 0. He repeats this process 6 times, building a stack of 6 lines from bottom to top. Each line is independent. Each line is binary. Each line represents one of 2 fundamental forces in the universe, yin or yang, dark or light, receptive or active, feminine or masculine, cold or hot, earth or heaven. The ancient Chinese saw everything, absolutely everything, as the interplay of these 2 principles, not good versus evil, mind you. That's a Western obsession. This is about balance, complementarity, the dynamic dance between opposites that creates all existence. Heavy stuff for a Thursday night. I know, but here's where it gets wild. These 6 lines, stacked together, create what's called a hexagram. Do the math, real quick. 2 options per line, 6 lines total. That's 2 times 2 times 2 times 2 times 2 times 2 times 2, which equals 64 possible combinations. The I Ching catalogues all 64 of them. Each hexagram has a name, a meaning, associated wisdom about change and transformation. It's basically a database, a lookup table. You input a 6-digit binary code, you get an output of philosophical guidance. Sound familiar? It should, because that's literally how computer memory works. You store information as patterns of 1s and 0s, and when you need it, you look it up based on its binary address. The ancient Chinese built a complete system of 64 unique states using only 2 symbols systematically combined. They created binary notation before anyone called it that. Before anyone thought of it as math. They thought they were mapping the cosmos. Turns out they were also mapping the fundamental logic that would eventually run our entire technological civilization. Now you might be thinking, okay, cool coincidence, but surely this didn't actually influence computers, right? The engineers who built the first computers weren't reading ancient Chinese philosophy, were they? Well, not directly. But here's the thing about ideas. They travel, they transform. They hide in plain sight for centuries, waiting for the right moment. the right mind to recognize their power. Let me introduce you to a brilliant kind of arrogant, definitely obsessive German philosopher named Gottfried Wilhelm Leibniz. It's the late 1600s, and Leibniz is having a productive century. He's co-inventing calculus, arguing with Newton about who did it first, developing theories of logic, metaphysics, and basically trying to figure out everything. Classic overachiever. One of Leibniz's pet projects is developing a perfect universal language, a way to express all human knowledge in logical symbols. He's also playing around with a weird number system that only uses 2 digits instead of the normal 10. He calls it binary arithmetic. Now, most of Leibniz's colleagues think this binary thing is a cute mathematical curiosity, but ultimately pointless. Why would anyone want to count using only 0 and 1 when we have perfectly good fingers for counting to 10? Leibniz is undeterred. He's convinced there's something profound, almost mystical, about the simplicity of binary creation from nothing. 1 emerging from 0. It resonates with his philosophical and theological ideas. Then, in 1697, something extraordinary happens. Leibniz receives a letter from a French Jesuit missionary named Joachim Bouvet, who's living in China. Bouvet has become fascinated by the I Ching and sends Leibniz a detailed description of the hexagram system. He includes diagrams showing all 64 hexagrams arranged in a particular order. Leibniz looks at these diagrams, his eyes go wide, his hands probably start shaking a little, because he immediately recognizes what he's seeing. The hexagrams are binary numbers. Every single one of them, the solid lines are 1s, the broken lines are 0s. Reading from bottom to top, each hexagram is a 6-digit binary number, arranged in perfect sequential order from 00000 to 11111. The ancient Chinese had been working with binary for 3,000 years. Leibniz is absolutely thrilled. He writes back to Bouvet immediately. He publishes papers about this amazing discovery. He sees it as confirmation that binary arithmetic isn't just his weird hobby, it's a fundamental truth about reality that wise men on the other side of the world had independently discovered millennia ago. This moment, this letter, this connection across cultures and centuries plants a seed. Binary goes from being Leibniz's eccentric side project to something with ancient wisdom backing it up, something that smart people should take seriously. Now here's where I need to pump the brakes a little on the hype. The I Ching didn't directly cause computers. Leibniz's binary system didn't immediately lead to microchips. History is messier than that. After Leibniz died in 1716, binary arithmetic mostly sat dormant for over a century. It was known, it was published, but nobody was doing much with it. No practical applications, no machines using it, just a mathematical oddity gathering dust in academic papers. Meanwhile, the Industrial Revolution happens. Mechanical calculators get built. Charles Babbage designs his analytical engine, a mechanical computer that runs on gears and punch cards. All of these use decimal arithmetic, base 10, because that's what humans are used to. Binary remains in the shadows. Then the 20th century arrives, and everything accelerates. In the 1930s and 40s, several things happen almost simultaneously in different parts of the world. Engineers start building electronic calculating machines for military and scientific purposes. They're using vacuum tubes, and later transistors, electrical components that have a natural property. They're either on or off, current flows or it doesn't. Voltage is high or low. These components are inherently binary. And a handful of brilliant people, working independently, have the same realization. If our electrical components are naturally binary, and if we need to do logical operations, Maybe we should build our machines around binary arithmetic. Claude Shannon, a master's student at MIT, writes what might be the most important thesis in history in 1937. He shows that electrical circuits can perform Boolean logic, the algebra of true and false, using simple switches and gates. Oregon gates, not gates. All of it maps perfectly onto binary. True is 1, false is 0, on is 1, off is 0. Every logical operation can be built from binary components. This is the foundation of all digital computing. Every computer ever built uses Shannon's insights. Your phone, your laptop, the servers running YouTube, all of it is electrical circuits performing Boolean logic on binary numbers. And Boolean logic, developed by George Boole in the 1850s, is itself an extension of the same dualistic thinking. True or false, 1 or 0, yin or yang, the conceptual thread runs through all of it. Not a direct line, more like a web of influences, ideas building on ideas across time and culture. The I Ching preserved binary thinking as something profound. Leibniz has recognized and formalized it mathematically. Boolean created the logical framework, Shannon implemented it in circuits, and the computer age began. Let's dive deeper into what makes binary so special, because I know some of you are thinking, okay, fine, 1s and 0s, big deal. Why is that better than any other number system? Great question. Let me break it down. Binary is robust. When you only have two states to distinguish between, it's incredibly hard to make mistakes. Imagine you're trying to communicate by flashing a light. If you need to signal 10 different values, you need 10 different brightness levels. That's tough. A little flicker, a little voltage drop, and suddenly your 8 looks like a 7. Chaos ensues. But if you only need to signal 2 values, light on or light off, you've got a huge margin for error. The light can be dimmer than expected, and it's still clearly on. It can flicker a bit, still on. Binary is fault tolerant. This is exactly why digital technology took over from analog. Analog signals degrade. Noise creeps in. Every time you copy a VHS tape, remember those, the quality gets worse. But digital signals, binary signals, can be perfectly copied infinite times. Because you're not trying to preserve an exact voltage level. You're just asking, is this a 1 or a 0? That's a yes or no question. And those are easy to answer reliably. The ancient Chinese, in creating the I Ching, chose the most robust possible system for preserving and transmitting information, broken or unbroken. There's no room for ambiguity. A line is clearly one or the other. This wasn't an accident. It was wisdom. Simplicity is reliability. Now let's talk about what actually happens inside your computer. Right this second, as you watch this video, your device contains billions of transistors. These are tiny switches, microscopic, really etched into silicon. Each one can be on or off. Each one represents one bit, one binary digit. String 8 bits together, you get a byte. A byte can represent 256 different values, from 00000000 to 111111. That's enough to represent any character in the English alphabet, plus numbers, punctuation, and a bunch of other symbols. Your computer's memory is just vast collections of bytes, each one storing a pattern of 1s and 0s. Your hard drive is the same thing, just stored magnetically or on flash memory instead of in active transistors. Every photo, every song, every video, it's all encoded as massive sequences of binary digits. The video you're watching right now is probably compressed using something like H.264 encoding. At its core, it's breaking the visual information into blocks, analyzing the patterns, and representing them as efficiently as possible using binary numbers. Your processor, the brain of your computer, is constantly performing operations on these binary numbers, adding them, comparing them, moving them around, transforming them. Every operation, no matter how complex it seems, breaks down into simple steps. Each step is a logical operation on binary values. Let me give you a simple example. Let's say your computer needs to add two numbers, 5 plus 3. In binary 5 is 101, and 3 is 0, 1, 1. Your processor has circuits specifically designed to add binary numbers. It processes each digit position, carrying over when needed, just like you learned in elementary school, but with only 2 digits instead of 10. The answer is 1000, which is 8 in decimal. That addition happens in a few billionths of a second. Your processor can do billions of these operations every second. And all of it, every single operation, is just patterns of ones and zeros, flowing through circuits, switches opening and closing, electrons moving or not moving. Yin and yang, dancing at the speed of light. When you really sit with that, it's kind of beautiful. The entire digital world, all of human knowledge on the internet, every app, every game, every social media post, it all reduces to the simplest possible duality, on or off, present or absent, yang or yin. The I Ching taught that all the complexity and change in the universe emerges from the interplay of two fundamental forces. Modern computing proves that principle in the most literal way possible. Infinite complexity, from binary simplicity. Now let's address something that might be bugging you. Did the ancient Chinese actually understand what they were doing, mathematically? Were they consciously working with binary arithmetic? The answer is no, not in the way we think of it. They weren't doing binary math. They weren't calculating in base 2. But here's the thing. They understood something deeper than arithmetic. They understood that a system of two complementary opposites, systematically combined, could represent all possible states of change. They understood that you could build complexity from simplicity. They understood that the pattern matters more than the components. Those insights are mathematical even if they weren't expressed mathematically. It's like how birds understood aerodynamics long before humans formalized the physics of flight. The knowledge was there, embedded in practice and philosophy, waiting for someone to recognize its mathematical nature. Leibniz was that someone. He saw the math in the mysticism. And by making that connection explicit, by showing that the I Ching hexagrams were mathematically equivalent to binary numbers, he validated binary arithmetic as more than just an abstract curiosity. He showed it had deep roots in human wisdom. Fast forward to the 1940s and 50s, when the first real computers are being built. I Ching, the first general-purpose electronic computer, goes online in 1945. It's a monster, weighing 27 tons, filling a large room, consuming 150 kilowatts of power. It uses 17,468 vacuum tubes, each one a switch that can be on or off. And I Ching actually uses decimal arithmetic, not binary, because its designers are still thinking in human terms. Base 10 feels natural, but I Ching is also notoriously unreliable. Vacuum tubes burn out constantly. Debugging is a nightmare. Engineers quickly realized that binary would be simpler, more reliable, easier to build and maintain. The next generation of computers, machines like EDVAC and UNIVAC, switch to binary, and binary becomes the standard. Every computer from then on uses binary at its fundamental level. Some computers have been built using ternary, base 3 or other systems, but binary has won. It's simpler, it's more reliable, it maps perfectly onto physical reality at the quantum level. Even in quantum computing, where you have qubits that can be in superposition, the measurement still collapses to binary, 1 or 0, yin or yang. Here's something that'll bake your noodle. The I Ching has 64 hexagrams. Modern computers use 64-bit processors. That's not a direct connection, but it's a fun coincidence. A 64-bit processor can work with binary numbers up to 64 digits long, which means it can represent numbers up to about 18 quintillion. That's a lot of counting from just ones and zeros. If the ancient Chinese had stacked one more line, making heptagrams instead of hexagrams, they'd have had 128 combinations, 7-bit binary, but they stopped at 6. Why? Nobody knows for sure. Maybe 6 felt balanced. Maybe the divination process naturally yielded 6 choices. Maybe they tried 7 and it felt like too much. Whatever the reason, they landed on a system that's mathematically elegant and practically powerful. Let's talk about how this affects you personally. If you're a programmer, understanding the binary foundation of computing changes how you think about code. Every variable, every data structure, every algorithm, it all compiles down to binary operations on bits. When your code feels slow, it's because the processor is doing too many binary operations. When your app crashes, it's because some binary value ended up in a state the code didn't expect. Understanding binary helps you think more clearly about memory, about data types, about performance. But even if you're not a programmer, binary thinking is useful. Binary questions are often the most powerful. Yes or no, will I do this or won't I? Is this acceptable or unacceptable? Binary thinking cuts through ambiguity. The I Ching uses binary combinations to map nuance and complexity, showing that binary doesn't have to be simplistic. 6 binary choices give you 64 distinct states. That's enough to capture a surprising amount of nuance. Your own life probably involves more binary choices than you realize. Every decision is ultimately a fork. You'll go left or right. Do it or don't. Say yes or no. Understanding that can be clarifying. It can also be limiting if you forget that most binary choices are part of larger patterns. Just like in the I Ching, it's the combination of choices, the pattern they create together, that determines the meaning. Now let's journey into the philosophy behind all this, because the I Ching isn't just a clever counting system. It's a profound meditation on change, balance, and the nature of reality. And those philosophical insights turn out to be surprisingly relevant to understanding computation. The core idea of the I Ching is that everything changes. Nothing is static. The universe is in constant flux. But change isn't random. It follows patterns. It has structure. And those patterns can be understood, even predicted, if you know how to read them. The 64 hexagrams represent 64 archetypal situations, 64 patterns of change. Each one describes a particular dynamic, a particular balance of forces, and crucially, the hexagrams themselves can change. In traditional I Ching divination, some of your 6 lines might be changing lines, a yin becoming yang, or yang becoming yin. So you don't just get one hexagram, you get a before and after, a transformation. The wisdom comes from understanding where you are and where you're headed. This is remarkably similar to how computer programs work. A program is a description of state changes. You start with an initial state, some binary values in memory. You execute instructions that transform those values. You end up in a new state. The program is the pathway of transformation. Conditional logic, if statements, are exactly like changing lines in the I Ching. If this condition is true, go this way. If false, go that way. A single bit can determine which path the entire program takes. That's a changing line, determining which hexagram you're moving toward. Loops in programming are like cyclical patterns in the I Ching. You repeat a process until a condition changes. You're watching for the moment when yin becomes yang, when the loop should exit. The I Ching teaches that you should align yourself with the natural pattern of change, not fight against it. In programming, we call this working with the grain of the system, writing code that matches how the computer naturally works, rather than forcing awkward solutions. Binary operations are natural to computers. Trying to do base 10 arithmetic in binary is awkward and slow. The computer has to simulate it. But binary operations, shifting bits, and ting, ting, those are native, they flow. They align with the Tao of the machine. There's an old book called The Tao of Programming, written in 1987 by Geoffrey James. It's a humorous but insightful collection of parables about software development, written in the style of Taoist wisdom. It makes jokes about ancient masters achieving enlightenment through debugging. But underneath the humor, there's real wisdom. The best programmers do have a kind of Taoist approach. They work with simplicity. They avoid forcing solutions. They watch for patterns. They know when to act and when to wait. They understand that complexity emerges from simple rules. All principles you can find in the I Ching. Let me tell you about yin and yang more specifically, because there's a lot of misunderstanding about these concepts in the West. Yin and yang are not opposites in the sense of enemies. They're not good versus evil. They're complementary forces that need each other to exist. Yin is receptive, yielding dark, cool, feminine, earth, valley, water. Yang is active, asserting, bright, warm, masculine, heaven, mountain, fire. Neither is better. Neither can exist alone. They define each other. Day needs night. Activity needs rest. Expansion needs contraction. This is different from Western dualism, which often sets up hierarchies: heaven above, earth below, good versus evil, mind over matter. The Chinese approach is more balanced. Yin and yang are equal partners in an eternal dance. And here's the kicker. In computing, 0 and 1 are exactly like yin and yang. Neither is more important. You need both. A program that's all ones is just as useless as a program that's all zeros. It's the pattern, the interplay, the balance between them that creates meaning. In the I Ching, too much yang is as problematic as too much yin. A hexagram of 6 unbroken lines represents heaven, pure yang, creative force. Sounds great, right? But the traditional interpretation warns of arrogance, overextension, the dragon flying too high. Balance is wisdom. In your computer, this manifests as the importance of both setting bits, making them 1, and clearing bits, making them 0. Programs that only set bits without ever clearing them will overflow, run out of memory, crash. You need the yin of clearing, of returning to 0, of emptying, as much as the yang of creating, of filling, of building. Let's talk about something practical. How do computers actually store information as binary? Because it's one thing to say everything is ones and zeros, it's another to understand what that physically means. In your computer's RAM, random access memory, each bit is stored as an electrical charge in a tiny capacitor. Charged is 1, uncharged is 0. These charges leak away quickly, which is why RAM is volatile. Turn off the power, the pattern disappears. The yin returns everything to emptiness. On your hard drive, if it's a traditional spinning disk, bits are stored as magnetic orientations. A tiny region of magnetic material points north or south. North is 1, south is 0, or vice versa. The read-write head can detect these orientations and flip them as needed. In solid-state drives, flash memory, bits are stored as trapped electrons in floating gate transistors. Electrons present means 1, absent means 0. The technology is different, but the principle is the same. 2 distinguishable physical states representing binary values. Even in cutting-edge technology like DNA storage, where data is encoded in artificial DNA sequences, it ultimately maps back to binary. Each base pair position can be one of four nucleotides, A, T, G, or C, but we encode binary data by pairing them. A and T might be 0, G and C might be 1, or you use combinations. Two base pairs give you four possible states, which encodes 2 bits. Everything comes back to binary, because binary is the simplest way to reliably store and retrieve information. You're minimizing the number of states you need to distinguish. You're maximizing your error tolerance. The ancient Chinese, sitting with their yarrow stalks, asking questions about the nature of change, stumbled onto this same principle. 2 clear states, systematic combination, pattern as meaning. Let me share something that blew my mind when I first learned it. The genetic code DNA is not binary, it's quaternary, base 4 nucleotides. But the way evolution optimized it is fascinating. DNA stores information incredibly densely. Each nucleotide is one of 4 options, which means each position stores 2 bits of information, and the way DNA replicates, repairs errors, and expresses information through RNA and proteins, it's all about pattern recognition and state changes. Reading sequences, matching complementary bases, transforming one pattern into another. The processes are remarkably computational, and they predate human consciousness by billions of years. Life itself discovered that information can be stored as patterns of discrete states, systematically combined and transformed. The I Ching is humanity's philosophical recognition of this same principle. Computing is our technological implementation of it, and DNA is nature's original version, refined over eons. 3 different domains, philosophy, technology, biology, all converging on the same insight. Information is pattern. Pattern emerges from combination. Combination works best with simple, distinct states. Binary is optimal for many purposes, but even when you use more states, you're still building on the same foundation. Let's zoom out for a moment. Why does any of this matter? Why should you care that ancient Chinese philosophy connects to modern computing? Here's my answer. Understanding where ideas come from deepens your relationship with them. When you know that binary isn't just an arbitrary engineering choice, but a principle that wise people across cultures and centuries have recognized as fundamental, it changes how you see it. You start to notice binary patterns everywhere. In nature, in decisions, in the structure of thought itself. You realize that ones and zeros aren't limiting, they're liberating. They're the simplest foundation you can build anything on. And also, it's a beautiful reminder that wisdom is universal. The ancient Chinese sages and the modern computer engineers are asking the same questions, seeking the same truths. How do you represent complexity? How do you build reliable systems? How do you understand and predict change? The tools are different, yarrow stalks versus silicon chips, but the insights are timeless. Let's get into some specific stories about how binary thinking shaped computer science, because the connection isn't just philosophical. There are concrete moments where binary made all the difference. When Claude Shannon was working on his master's thesis in 1937, he was employed at MIT running the differential analyzer, a massive mechanical computer that used gears, wheels, and shafts to solve equations. It was impressive but clunky. Shannon was also studying Boolean algebra, the logical system developed by George Boole in the 1850s. Boole had created an algebra where variables could only be true or false, and you could combine them with operations like and, Oregon, and not. Shannon had a revelation. The mechanical relays and electrical switches in telephone systems, where he'd also been working, behaved exactly like Boolean variables. A switch is open or closed, true or false. 1 or 0. Shannon realized you could build electrical circuits that performed logical operations, wire two switches in series, and current only flows if both are closed. That's an AND gate. Wire them in parallel, and current flows if either is closed. That's an OR gate. Add a switch that inverts the signal, and you've got a NOT gate. From these three basic operations you can build anything. Any logical statement, any calculation, any program. Shannon's thesis, a symbolic analysis of relay and switching circuits, is the foundation of digital circuit design. It showed how to translate Boolean logic into electrical circuits. And Boolean logic operates on binary values, true or false, 1 or 0, yin or yang. Without Shannon's insight, computers might have developed very differently. We might have stuck with analog computers, which are fast for certain problems, but notoriously difficult to program and prone to errors. Digital binary computing won because it's reliable, flexible, and mathematically elegant. And it won partly because Shannon recognized the connection between logic and electronics, both of which are fundamentally binary. Here's another story. When the first transistor was invented at Bell Labs in 1947, it was a huge breakthrough. Transistors could switch electrical signals much faster than vacuum tubes, using far less power, but transistors are even more naturally binary than vacuum tubes. A transistor is either conducting or not, saturated or cut off. There's not much middle ground. Trying to use transistors for analog signals is possible, but tricky, their happiest being on or off. This physical reality pushed computer design even more firmly toward binary. When integrated circuits came along in the 1960s, packing hundreds, then thousands, then millions of transistors onto a single chip, binary logic was the obvious choice. You could etch tiny transistors, connect them into logic gates, and build incredibly complex circuits, all of it binary at the lowest level. The engineers designing these systems weren't thinking about the I Ching, they were thinking about voltage levels, switching speeds, power consumption, but they were working within constraints that made binary the natural solution, and those constraints are themselves expressions of fundamental physics. Particles have spin up or down. Electrons are present or absent. Magnetic domains point one way or the other. The universe at its quantum foundation is full of binary distinctions. The I Ching in recognizing yin and yang as fundamental was tapping into something deep about reality, not just human psychology or cultural preference, but the actual structure of the physical world. Binary is everywhere once you start looking. Day and night, alive or dead, matter and antimatter, particle or wave, though quantum mechanics complicates that one. Even in mathematics, the simplest number system that can represent all integers is binary. You can't do it with just one symbol. You need at least two, 0 and something else. Absence and presence, the minimum viable complexity. Let me tell you about a programmer I admire named Donald Knuth, widely considered one of the greatest computer scientists ever. He wrote a massive, still unfinished series of books called The Art of Computer Programming. In it he explores algorithms, data structures, and computational thinking at a deep level. Knuth has said that understanding binary arithmetic and bit manipulation is essential for any serious programmer. Not because you'll write binary code directly, most of us don't, but because understanding how data is actually represented shapes how you think about problems. When you know that an integer is stored as 32 or 64 bits, you understand why certain numbers are limits, why 2 billion is a common maximum value for an integer. It's not arbitrary, it's 2 to the 31st power minus 1, the largest number you can represent with 31 bits, saving 1 bit for the sign. When you understand binary, you can do clever tricks. Need to check if a number is even. Look at the last bit. If it's 0, the number is even. If it's 1, it's odd. That's instant. No division required. Need to multiply by 2. Shift all the bits 1 position to the left. Need to divide by 2. Shift right. These operations are incredibly fast because they align with how the hardware actually works. Nuth also writes about the beauty of binary, how it's pure, minimal, elegant, how algorithms expressed in binary often reveal their true structure. There's an aesthetic dimension to binary thinking. It's not just practical, it's beautiful. The I Ching has that same quality. The hexagrams are visually striking, simple lines arranged in patterns, no unnecessary decoration. The form reflects the content, simplicity revealing depth. In programming, we talk about elegant code, code that does what it needs to do with minimal complexity, code where the structure is clear and the logic is obvious. That's the same principle as the I Ching hexagrams or binary arithmetic. Removing everything non-essential, letting the pattern speak. Now, I want to address a common misconception. Some people think that because computers use binary, they can only think in black and white terms, that they can't handle nuance or ambiguity. This is completely wrong. Yes, at the lowest level, everything is ones and zeros, but the patterns of ones and zeros can represent anything. Collars, sounds, probabilities, fuzzy logic, neural networks that recognize faces or translate languages. All of it is binary underneath. Just like the I Ching uses 6 binary lines to represent 64 nuanced situations, computers use billions of bits to represent unlimited complexity. Binary is the foundation, not the limit. In fact, binary enables more complexity than analog systems. Because binary can be perfectly copied, transmitted, transformed, you can build layers of abstraction, machine code on top of binary, assembly language on top of machine code, high-level languages on top of assembly, libraries and frameworks on top of high-level languages. Each layer adds meaning, but it all compiles down to binary. The I Ching works the same way. The lines are simple, but the interpretations are rich. Layers of commentary have been added over centuries. Confucian readings, Taoist readings, modern psychological readings. The binary foundation supports infinite interpretation. Let's talk about quantum computing for a minute, because it's the next frontier and it relates to this in interesting ways. Quantum computers use qubits instead of classical bits. A qubit can be in superposition, simultaneously 0 and 1 until measured. This sounds like it breaks the binary paradigm, but it doesn't. When you measure a qubit, it collapses to either 0 or 1. The computation takes advantage of superposition, but the final result is still binary. Quantum computing is powerful because it can explore multiple binary paths simultaneously. It's like consulting multiple I Ching hexagrams at once, then collapsing to the one that answers your question. The foundation is still binary, but the processing is different. And interestingly, some people have drawn connections between quantum superposition and Taoist philosophy. The idea that things exist in undefined states until observed. That reality is probabilities until it crystallizes into actuality. I'm not enough of a physicist to say whether those connections are meaningful or just poetic, but they're certainly thought-provoking. What I can say is that even as computing evolves into quantum realms, binary remains foundational. The qubit has 2 basis states, 0 and 1. Superposition is a combination of those states. You can't escape the binary foundation. Yin and yang, all the way down. Here's a thought experiment. Imagine you're trying to build a communication system with an alien civilization. You have no common language, no shared cultural references. What's the most basic thing you could transmit? Many scientists think it would be binary, on-off patterns, pulses and silences, because any technological civilization would understand counting, and binary is the simplest counting system. You could send the binary representations of prime numbers to prove you're intelligent. Prime numbers are mathematical truths that transcend culture, and binary is the purest way to express them. The I Ching, in a weird way, is humanity's message to itself across time. It's saying, here's a fundamental truth we've discovered. Reality has structure. That structure emerges from duality. You can map complexity with simplicity. And thousands of years later, we're still unpacking that message, still finding new applications. Let's bring this home to your daily life, because I don't want this to just be abstract philosophy and computer history. This connects to how you live right now. Every decision you make is a bit flip. Every choice between two options is a binary operation on the state of your life. And here's the interesting part. Small binary choices, compounded over time, create vastly different outcomes. Just like in the I Ching, where changing one line in a hexagram can completely alter the meaning, changing one decision in your life can set you on a totally different path. Programmers understand this viscerally. One incorrect bit in a program can cause a crash. One wrong branch in the logic can produce completely wrong results. The butterfly effect is real in code, and it's real in life. What the I Ching teaches is to pay attention to these decision points, to recognize when you're at a fork, to consider the pattern you're building with your choices. Each binary decision is part of a larger hexagram. You're constructing the story of your life, 6 lines at a time, or 60 or 6,000. The pattern matters. Modern life bombards you with choices, infinite options, infinite complexity, but most of those choices are false complexity, distractions. The important choices are usually simple. Binary: will you do the work, or won't you? Will you be honest, or won't you? Will you show up, or won't you? These are the lines you're drawing, and the hexagram they form determines the trajectory of your life. There's power in recognizing that, in cutting through the noise and identifying the real binary choice in front of you. Not which of 30 streaming shows to watch, but whether to watch anything at all or do something else. Not which of 100 career paths to choose, but whether to take action today or postpone. Binary thinking clarifies. And once you've made the binary choice, once you've drawn the line, you move to the next one. You don't agonize about whether the line should be broken or unbroken. It is what it is. You made the choice, now you make the next choice. This is how programs execute. One instruction at a time. The processor doesn't worry about the instruction it just finished. It moves to the next one. Sequential execution, progress through binary decisions. There's a meditative quality to this. Being present with the choice in front of you. Making it. Moving on. The I Ching was used for divination, but it's also a tool for decision making. When you're confused about what to do, you consult it. You ask your question, you generate a hexagram through a random process, and then you read the associated wisdom. Now you might think that's just superstition, random chance determining your choices. But there's something deeper happening. The randomness breaks you out of your habitual thinking. It gives you a perspective you wouldn't have considered. And the wisdom in the I Ching is general enough to apply to many situations. It's like a mirror that reflects your question back at you from an unexpected angle. Programmers use a similar technique called rubber duck debugging. When you're stuck on a bug, you explain your code out loud to a rubber duck. Sounds ridiculous, but it works. The act of explaining forces you to think differently. You notice things you missed. The duck doesn't actually help. The process of talking to it does. The I Ching is an ancient rubber duck. The hexagram doesn't magically know your situation, but the process of consulting it, of contemplating the wisdom associated with that hexagram, helps you think more clearly. Binary outcomes from a process that bypasses your overthinking. Let me share a personal story. That I Ching process that I Ching you can I once was stuck on a difficult decision about a career change. Lots of uncertainty, lots of variables. I was paralyzed by trying to predict every outcome. A friend suggested I simplify it. What's the binary version of this choice? Stay or go? Not stay but negotiate better terms, or go but to which option, just the core binary. Stay or go. That clarity helped. I realized I'd already decided to go. All the complexity was just fear and rationalization. The binary choice was clear. I just needed to acknowledge it. That's the power of binary thinking. It cuts to the core, yin or yang, 0 or 1, yes or no. Everything else is elaboration. And here's the beautiful paradox. By embracing the simplicity of binary choices, you can navigate tremendous complexity. Your computer is doing exactly this. Billions of simple binary operations per second, creating the appearance of smooth video, rich graphics, complex calculations. Your life can work the same way. Binary choices made with clarity and intention compound into a complex and meaningful existence. The I Ching understood this 3,000 years ago. One decision at a time, one line at a time, build the hexagram. Let's talk about information theory, because it ties all of this together. Information theory, developed by Claude Shannon, yes, the same Shannon from earlier, in 1948, provides a mathematical framework for understanding information, and at its core is the bit, the binary digit. Shannon showed that you can measure information in bits. The amount of information in a message is related to how many yes or no questions you'd need to ask to reconstruct it. If I'm thinking of a number between 1 and 8, you need 3 yes or no questions to guess it. Is it greater than 4? If yes, is it greater than 6? And so on. 3 binary questions, 3 bits of information. This is profound. Information isn't stuff, it's not physical, it's the reduction of uncertainty, and the fundamental unit of reducing uncertainty is a binary choice. Each bit cuts the possibilities in half. The I Ching is an information system in exactly this sense. Each line is 1 bit, 6 lines is 6 bits, 64 possible messages, enough to convey nuanced guidance, but not so many that it's overwhelming. It's information optimized for human comprehension. Shannon's information theory revolutionized communication. It explains how to compress data, how to correct errors, how to maximize the capacity of a communication channel. All of it based on binary thinking. All of it in a deep sense related to the same insights that the I Ching embodies. When you send a text message, it gets compressed, redundant information removed, patterns exploited, then it's transmitted as binary data, ones and zeros, electrical or optical signals. Then it's decompressed on the receiving end. The whole process is manipulating bits to efficiently transfer information. The I Ching is doing something similar, compressing the infinite complexity of a life situation into 6 bits. Transmitting it across time through the text, decompressing it in your mind as you read and interpret. Ancient information technology. Here's another connection that fascinates me. Error correction. Digital communication systems have built-in error correction. Extra bits are added to the message so that if some bits get flipped during transmission, the receiver can detect and fix the errors. The I Ching has a kind of error correction too. The changing lines. When you consult the I Ching, some lines might be designated as changing lines, meaning they're about to flip from yin to yang, or vice versa. This gives you 2 hexagrams, the present situation and the future situation. It's like the I Ching is saying, here's the message but also here's the error correction, here's the adjustment that's coming. It's a more nuanced reading that accounts for the fact that situations aren't static, they're in flux. Error correction in divination. I love it. Let's zoom back to computing. Modern computers don't just use binary for arithmetic. They use it for logic, for control flow, for everything. Every if statement in a program is a binary decision. The condition is evaluated to true or false, and the program branches accordingly. Loops continue or exit based on binary conditions. Function calls succeed or fail, return true or false. Even data structures are built on binary foundations. Binary trees, where each node has at most 2 children, are fundamental in computer science. They're used for searching, sorting, organizing data. The structure mirrors binary choices: go left or right, less than or greater than, yin or yang. And here's where it gets really meta. Machine learning and artificial intelligence, the cutting edge of computing, are built on binary foundations. Neural networks, which seem so complex and almost brain-like, are ultimately performing billions of binary operations. Each neuron in an artificial neural network takes inputs, performs a calculation, and produces an output. That output is often passed through an activation function that makes a kind of binary decision. Is the signal strong enough to activate or not? These networks learn by adjusting the strength of connections between neurons, but the fundamental operations are still binary arithmetic and logic. An AI that can generate human-like text, or recognize images, or play chess better than any human, is doing it all with ones and zeros, yin and yang, at unimaginable scale and speed. So here we are, full circle, ancient Chinese philosophers contemplating the nature of change, representing it with broken and unbroken lines. Leibniz recognizing the mathematical beauty of that system. Shannon and other pioneers building it into electrical circuits. And now we're surrounded by devices that run on binary logic, descended in an unbroken line, pun intended, from those ancient insights. What can we take away from all this? First, ideas have long histories. Binary didn't just pop into existence when the first computer was built. It's been part of human thought for millennia, expressed in different languages, serving different purposes, but fundamentally the same insight. Second, simplicity is powerful. 2 symbols, systematically combined, are enough to represent anything. You don't need complexity at the foundation. You need clarity. Complexity emerges naturally from simple rules applied consistently. Third, Eastern and Western thought have more in common than we often assume. The I Ching and computer science seem like they're from different planets, but they're asking the same questions and finding the same answers. Wisdom is universal. Fourth, understanding the foundations changes how you see the surface. When you know that your phone is billions of transistors making binary decisions, it's not magic anymore. It's comprehensible. Impressive, but comprehensible. And that's more satisfying than magic. Fifth, binary thinking, yes or no, yin or yang, can be a tool for clarity in your own life. When you're overwhelmed by complexity, look for the binary choice. What's the core decision? Everything else is noise. If you're a programmer, I hope this gives you a deeper appreciation for the tools you use every day. Binary isn't just a technical necessity, it's a philosophical principle with ancient roots. When you write code, you're participating in a tradition that goes back thousands of years. If you're not a programmer, I hope this helps you see that technology isn't separate from human wisdom and culture. It's an expression of it. The same impulses that led ancient sages to contemplate yin and yang led modern engineers to build computers. We're all trying to understand and navigate complexity. Let's talk about where this goes next. Computing is evolving. We're developing quantum computers, neuromorphic chips that mimic brain structures, DNA computing, optical computing. Will binary remain foundational? Probably. Even quantum computers rely on binary measurements. Even brain-inspired chips use binary neurons firing or not. Binary seems to be baked into the structure of information itself, but maybe we'll discover something beyond binary. Maybe there's a ternary or quaternary system that's even more fundamental. The universe has more than 2 states at the quantum level. Particles have properties like spin that can have multiple values. Maybe future computing will exploit that. Or maybe we'll realize that binary is sufficient. that adding more states doesn't actually gain you much. That 2 is the magic number. The I Ching might have been right all along. Yin and yang, 0 and 1, are all you need. As we close, I want to leave you with a thought. The ancient Chinese scholars who developed the I Ching were trying to understand the universe. They were asking, what are the fundamental principles? How does change work? How can we navigate uncertainty? The engineers who built the first computers were trying to solve practical problems. How do we calculate faster? How do we process information reliably? How do we automate thought? They seem like completely different goals. Philosophy versus engineering, mysticism versus mathematics. But they converged on the same answer. Binary. 2 fundamental states, systematically combined. That convergence suggests something deep. Maybe binary isn't just a human invention. Maybe it's a discovery, a feature of reality itself. Maybe the universe is, at some level, computational. Information processing all the way down. Physicists are actually exploring this idea. The simulation hypothesis. The idea that physical reality might be a kind of computation. The holographic principle. The idea that information is more fundamental than matter. These are cutting-edge physics, but they echo ancient philosophy. The I Ching said that reality emerges from the interplay of yin and yang. Modern physics is finding that information, binary distinctions, might be the foundation of everything. I'm not saying the ancient Chinese predicted quantum mechanics. That would be a stretch. But I am saying that deep thinkers across cultures and centuries have recognized that duality, binary distinction, is fundamental. And now our technology proves it in the most practical way possible. Every device you own runs on that principle. So the next time you pick up your phone, take a second to appreciate the journey from yarrow stalks to silicon chips, from philosophical contemplation to global communication networks, from yin and yang to 0 and 1. It's all connected. It's all part of the same human quest to understand and shape our world. And maybe, just maybe, when your app crashes or your code doesn't compile, you can take a breath and think, I'm participating in a 3000-year-old tradition of working with binary logic. The ancient sages would understand my frustration. They'd probably smile and say, yes, this too is the Tao. Change is inevitable. Sometimes the line is broken. Sometimes the bit flips unexpectedly. That's not a bug, that's reality. Before we end, I want to hear from you. Have you ever thought about where binary comes from? Do you see connections between ancient philosophy and modern technology that I didn't cover? Drop your thoughts in the comments. And if you found this journey interesting, hit that subscribe button. We've got more explorations of how ancient wisdom connects to modern life coming your way. Tech history, philosophy, the hidden connections that make you see the world differently. Let me know what topics you'd like to see next. As you go back to your day, scrolling, typing, computing, remember that every tap, every click, every byte transferred is part of an ancient pattern. Yin and yang, 0 and 1. Broken and unbroken. The dance continues. You're part of it. We all are. The I Ching teaches that the wise person aligns with the pattern of change rather than resisting it. In our digital age, that might mean understanding and embracing the binary foundation of our technology, not fearing it, not feeling overwhelmed by it, but recognizing it as a simple, elegant principle that enables infinite complexity, 2 states, combined in patterns, creating everything, your photos, your messages, your memories stored in the cloud. All of it is yin and yang. All of it is ones and zeros. All of it is part of a continuum that stretches back to ancient China and forward to whatever computing looks like 1,000 years from now. The foundation will likely still be binary, because some truths are timeless, some insights are universal, Some patterns are fundamental. The ancient Chinese saw it, Leibniz recognized it, Shannon implemented it, and you're living it right now. So here's my challenge to you. This week, notice the binary choices in your life, not the complex decisions with dozens of factors, the simple ones, yes or no, do or don't, go or stay. Notice how those simple choices, made with intention, create the pattern of your days. Notice how, like in the I Ching, each choice is a line in a larger hexagram, and the hexagram tells the story. You're drawing the lines. Choose wisely, because those simple binary choices compound. They build on each other. They create your path, just like binary digits compound. To create complex programs, your choices compound to create a complex life. The principle is the same. Simplicity at the foundation, complexity emerging from pattern. And maybe if you're feeling contemplative, spend some time with the I Ching itself. You don't have to believe in divination. You don't have to take it as mystical truth, but read it as philosophy, as poetry, as an ancient meditation on change, balance, and pattern. You might find it speaks to you. You might find insights that apply to your modern life. Because wisdom doesn't age, truth doesn't become obsolete. The I Ching has survived for 3,000 years because it touches something fundamental, something that transcends culture and technology. The same thing that makes binary computing work: pattern, simplicity, the interplay of opposites, yin and yang, 0 and 1, broken and unbroken. It's all the same. It always has been. And as we build new technologies, as we push into AI and quantum computing and whatever comes next, we'll carry these ancient insights with us, because they're not just history, they're foundation, they're the ground we build on. So thank you for taking this journey with me. From the Yellow River Valley to Silicon Valley, from yarrow stalks to smartphones, from ancient philosophy to modern code. It's been a long, strange trip. But hopefully you see the connections now. Hopefully the next time you write a line of code or send a text or scroll through social media, you'll feel the echo of those ancient sages. They're still with us, in every bit, in every binary choice, in every pattern we create. The Taoist of computing is the Taoist of the I Ching. Simple principles, infinite complexity, two states, endless possibilities. Yin and yang, dancing forever. Until next time, keep thinking deeply, keep questioning, keep noticing the patterns, and remember everything is connected. Ancient and modern, East and West, philosophy and technology. It's all one story, and you're part of it. Hit that like button if this resonated with you. Subscribe for more deep dives into the hidden connections that shape our world. And let me know in the comments what blew your mind the most. I read every single one. Thanks for watching. Now go forth and appreciate the binary beauty all around you. The ones and zeros, the yin and yang, the broken and unbroken lines that make up our digital existence. It's all pretty amazing when you stop and think about it. See you next time.